Hello, algebra people of the world. Hope you're doing awesome today. Welcome to unit number 4. Wow, 4. Get excited. We got a whole bunch of stuff going on today in unit 4. Bad news for starters. Wave goodbye to the tall yellow calculators, right? They're going to stay in their charging cradles the rest of this unit, and say hello to the little red rectangle calculators. So if you need a calculator, you guys get the red ones for this unit. So the graphing ones stay on the sidelines, so to speak. They can be bench warmers. So anyway, unit 4, all about linear equations. We're not solving them, right? We are just graphing them. So we've solved these a whole bunch in our last unit, and we're going to be graphing them this unit. Again, they're linear equations, so all of these will give us straight lines. Right, here's just a little sampling of where we're at. We're going to try to get through as much as we can. Hopefully we'll finish up here before holiday break, and we can hopefully get back into some of those function stuff that I promised you. Anyway, first things first, we're going to talk a little bit about slope here today, and maybe what slope looks like. And slope is really just a number. Let's zoom in to about there. But here we go. What is slope? Well, that is the, we can also call slope rate of change, right? It's got a few synonyms. Rate of change and slope mean the same thing. And all slope is really just a number, right? Sometimes we see it as a fraction, so we can say, hey, it's a ratio between, and then we'll see this word a lot, rise and run. Rise, we're talking about our vertical movement up and down, right? So that would be on our y-axis. Run is our side-to-side movement. That, of course, is on our x-axis. And in this equation right here, which will be your new BFF for the next couple weeks, 4 letters there. One of those is slope, and that would be the letter M. That's amazing. Ha ha. I laugh at my own jokes. That's great. Okay, here's our 4 kinds of slope. All right, and we read slope kind of like we read a book, left to right. So if we look at our little animal creator, I don't even know what this thing is, some weird thing. Anyway, if we go left to right, it's increasing, right? This shows me positive slope. On the right-hand side, here it is going downhill. Again, left to right, it's decreasing. This is negative slope. Our creature is not moving at all on the third line here. This actually has a slope. It is 0, right? This has no change or no rate of change or no slope to it. And our last one, a vertical line, it's actually changing so much we can't even define how much it's changing. So vertical lines have an undefined slope. And then down here you're going to see this, and I mentioned this earlier, but slope is just rise over run, right? How are our y values changing with respect to our x values? Some people might say triangle y over triangle x. The triangle is really just the delta symbol from the good old Greek days. Delta y over delta x. Delta just means change. So how are your y values changing with respect to your x values? So let's take a look. Slope, again, just a number. That's all it is. It's going to be a positive number. It could be a negative number. It might be 0. Can even be a fraction too, right? We're okay with that as well. Again, that's why we called it a ratio. In order to find slope from a graph, that's what we're going to look at first. We pick any 2 points on our line we want. Well, I say that. We can't pick any 2 points. I need to pick points that go through, right, an intersection, just like this one does. It goes right through the intersection of those 2 lines, if we think about that being, -2, and actually both of those are -2, right? This point here doesn't go through any intersection of lines on my x and y axis, right? Neither does this, nor does that. This one is pretty close, but no. All right, again, nothing there. So for slope, it's really just, hey, rise over run. So I'm going to move from this dot down here. I'm going to move up, and then I'm going to move to the right. Now, we call moves that go up, or when we move to the right, those are positive moves, right? Because those numbers are increasing. As I go up, my numbers are increasing. As I go to the right, my numbers are increasing. That will help me figure out if I've got positive or negative slope. As I go down, or as I go to the left, right, those are negative moves, or my numbers are decreasing. That's why we call those negative. Again, I could look at number one and say, hey, this, if I read it left to right, this has positive slope. But we can also do that just with our moves here. So again, I'm going to start down here, and we're just going to count up until I get up to here, and then we're going to go to the right. So I'm going to go up 1, 2, 3, 4, 5, 6, 7. I went up 7, so I'll write that with a plus 7. And that gets me here, and now I've got to move to the right. So 1, 2, 3, 4. So that's 4 to the right. So that's a positive 7 divided by a positive 4. Simplify your fractions if you have them, and we'll call this a slope of 7/4. All right. Again, it doesn't matter what 2 points we use or what 2 points we go through. And what I mean by that is I've got some other good points on here, right here and here. Right, and so I've got 4 points now. It doesn't matter which of those 4 points I use as long as I'm using 2 of them. I'm going to start at the top left one, and I'm going to move down, and then I'm going to move to the right. Again, down is a negative move, right is a positive move. So we're going to move down 1, 2, 3. That gets me here. So I went down 3, negative 3. To the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a positive 9. Positive 9. So negative 3 divided by positive 9. I just need to simplify this, right? This is negative 1/3 as a slope. We like to see slope as a fraction. That's actually easier, believe it or not, than if I have a whole number. Okay, this is one of our special cases. Again, horizontal line, so you might be able to look at this right off the bat and say, yep, 0 slope here. But here's how if we would actually, compute it, here's how it works. So I'm going to move from this dot to the one on the right. So vertically, does it move up or down at all? No. So that's 0. And then it moves to the right just 1. So right 1 is a plus 1 or a positive 1. 0 divided by 1, well, that's just 0. So that's why that one works out. Didn't need to do that. Let's move over here. All right. Here's the other special case that we have. Again, vertical line. You can remember that a vertical line is just undef, as I like to call it, or undefined. But mathematically, here's why this works out. Again, let's move from the bottom dot up here to the top one. So vertically, this moves 1, 2, 3. This is moved by 3. All right. Horizontally, though, it doesn't move at all, and that's the problem. We can represent that not moving with a 0. And if you try to take 3 and divide it by 0 on your calculator, it's going to give you an error. Really, any calculator, it'll say error divided by 0. You can't do that. We're okay if we have 0 and we divide that by any number. That's fine. But I can't do this because this problem does not exist. Neither does its slope. Okay? Let's check out what we got going on here in number 5. There we go. Again, points have already been picked for us. If we look closely, there's not too many points that I can use on here. The only other point, see if you can figure it out, there's only one other point that I could put on this line and use that to figure out slope, and that's this point all the way down here. I'm just going to go with what I've got here, so I'm going to go up, I'm going to go to the right. Both of those are positive moves. 1, 2, 3, 4, positive 5, right, over 1, 2, 3, positive 3. Fractions, like I said, are great. Just simplify them. We don't need to change this to a mixed number. Improper fractions are actually better than mixed numbers when it comes to slope. So 5/3, good to go there. Take a look at number 6. I've got 2 dots on here. Okay, let's take a look and see what we have here. I'll start here, and I'll move to the other dot. So we're going to start here. I'm going to go up 1, up 2. So that's a +2. Right, I went up first, always up, then left or right. To the right, I'm going to move 1, 2 as well. Again, that was also a +2. We divide those, and we get a slope of 1. All right, say goodbye to the first page. Second page, guys. So I want you go ahead, pause this, and I'm going to let you work through again. When you see one of the special cases, I see both of them there on this page. All right, you can just go ahead and write down what they are. It looks like I've been super nice in giving you dots on all of these. All right, just know that there's sometimes more, and know that sometimes we might not get the 2 points that we need to use. But go ahead, pause the video, work through these examples real fast. Give yourself some practice. Unpause the video. I'm just going to shoot through the answers real quick. If it doesn't make sense, you just raise your hand and call me over, and we'll get it so that it does. All right, go ahead and pause. Welcome back. Glad that you're back. Let's go ahead and we'll do some slope here, super quick. So number 7, and this is in no particular order. Number 7 is going to have a slope of -3. Okay. Number 8 has a slope of, let's see, this is 1, 2, 3. This is +4 over 1, 2, 3, 4 over +5. So this is going to be a slope of 4/5. Okay, number 10. This is, you would get 4 over 2, and then you would simplify that down to just 2. All right, number 11, we're up 1 and over 3, so that's a slope of 1/3. All right, let's move over. Let's get these two. Again, these are our special cases right here. So this one is 0 and undefined on 12. All right, let's take a look. Let's see if we can't do 4. There we go. 13, again, positive slope. This is a 4 over 1, right, which would simplify down just to 4. 14, again, positive slope. This goes up 2 and over 3, right? So we would say, hey, that's 2/3. 16, up 1 over 4. So you'd say positive 1 over 4, so 1/4 there. 17, this is a positive 4 over 2. Again, 4 over 2 or 4/2 is not my slope, but 2 certainly is. Okay, let's take a look at 15 and 18. Finally, we see some negative slope start to creep in. So this is -5 over a +1. That gives me -5 for a slope. And 18, again, we're going to move down, then we're going to move to the right. So that goes down 4 and to the right 1, 2, 3, 4 as well. So that's a -4 with a +4. We divide those, and I get -1. Okay, and last row. Again, negative slope on this one. It goes down 3 to the right 4. So -3/4. Looks good. On number 20, this goes down 2 and to the right 4. Again, it's not -2 over 4. It's just -1/2. All right, last one, positive slope. This one goes up 1, 2, 3, 4. It goes up 5 and over 2. So we're just going to call it 5/2. Okay, so all good there. Let's move on to this. Everybody, so here is our next page. You'll notice we have no graphs on this one, but what we do have are some ordered pairs. So we've got a pair of pairs, we'll call them. No, I'm not talking about fruit, but we're talking about x and y values. So we do have a handy formula, as we do for everything in math. So in other words, if I want to figure out what slope is, remember slope is m, we do something that looks like this: y2 minus y1 divided by x2 minus x1, right? This will help me find my slope. Again, I'm talking about the y values. How are they changing with respect to how our x values are changing? So formula is not that hard to use. I mean, we're just subtracting and then we're dividing. But what we do have to make sure we do, as there's 4 parts, right, y2 and y1, we have 4 numbers on here. If I put any number in the wrong place, bad things happen. So I like to say, and you can pick whichever ordered pairs you want. I'll pick one, I'll call it my first ordered pair. My other one obviously has to be my second ordered pair. In an ordered pair, remember, we have an x value and a y value. So we're going to call the first one here, I'm going to call that x1. I'm going to call the one on the right y1. 4 gets to be x2 because it's in our second ordered pair, and 3 gets to be y2. All right, now it's merely plug in your numbers where they should go. So y2 minus y1, x2 minus x1. Looks like that. So 3 minus 1, 2, and 3. So there we go. We get a slope of 2/3 for this one. Okay, looking at number 3, we'll just do the left-hand side here. Let's do that. Again, -4, I'm going to say is x1, 5 is y1, -8, x2, -5, y2. Be careful with negatives. Sometimes we'll end up with these double negatives. And as Mr. Knoll taught all of you, well, some of you last year, double negatives really mean adding. Then again, maybe some of you might have forgotten. Uh-oh. Maybe that's why you got to go spend Core 4 with Mr. Knoll if you need to. -8 minus 5. Okay, so there's our y2 minus y1. x2 minus x1, -8 minus, here we go, -4. There's that double negative. This should turn into -10. Right, this really means -8 plus 4, guys. That turns into -4. We can simplify here in 2 ways, right? Negative divided by negative, of course, gives me a positive. So we'd have positive 10/4, which we reduce as a fraction to 5/2, 5/2. Okay, number 5. Again, it's a silly habit, but until you get used to it, right, just label these out. We're going to end up with 9 minus 9. Those are y2 minus y1. And x2 minus x1, 3 minus 5. Okay, if you get a 0, just double check, make sure your arithmetic's right. Here I do believe 9 minus 9 is 0. Therefore, what is our slope? We don't just stop, right? We say, hey, this indeed has a slope of 0. Remember, on a graph, this would look like a horizontal line. All right, number 7. Again, here's x1 and y1. x2 and y2, so y2 minus y1, x2 minus, careful, double negative, 3 minus 9, -6, 2 minus -1, just 3. Simplify this down to -2, and we're good. Okay, take a look at, got a few more on here. I'll leave our formula out, as hopefully we're getting a little bit better with it. I'll leave naming x1 and y1 out. This will turn into 5 minus 6, and this is all over 6 minus 5. It's confusing with all those 5s and 6s. This turns into -1 over 1. Do a little bit of division. Slope of -1. And 11. Okay. -2 minus -9. Double negative again. I feel like it's just me against the world with these double negatives today, guys. And 3 minus 5. Here we go. This really means plus, that should be 7. That should be -2. And we can leave that, right? -7/2. Sounds good. So why don't you guys go ahead, give the video a quick pause, and let you guys try the formula on your own for a bit on the evens there, 2 through 12. Pause it, come back. I'll show you the answers on that. I'll write those down super quick, and we'll go from there, okay? All right, welcome back, everybody. Hope you're having a great Friday here in algebra class with me. So here's what we got going on. Number 2, answer on number 2 is -1. Hold on, -1. Wait for it. Half. Woo. All right, number 4. -1/3. Okay. Number 6. This is the old undef, right? This will be a vertical line if we were going to see that on a graph. Number 8 is -3/2. Haha, got you on that one. Okay, number 10. Ooh, no, that was good. 0 on number 10. And number 12, again, another undefined. Okay, again, don't think you did something wrong, right? If you get 0 or undefined on those, don't think you did anything wrong. Just go ahead and double check your arithmetic on there to make sure everything's good. So with that, guys, I'm going to give you an easy Friday. All right, here's your homework number 1. It doesn't look too bad. I've even picked some points out for you there on our graphs on 1 through 6. So why don't we give 1 through 15 a quick shot? That's your homework. Shouldn't be too bad. I'll let you even use whatever time we got left here today to do that. Okay. Hope you had a fun time listening to me through your earbuds instead of listening to me stand up in front of the smartboard. Have a great day.